Welcome, everybody. Thanks for joining. Okay, I'll give it a minute or two to everyone to enter the room. Okay, so I think I'm gonna kick it off. If all of you co-hosts could help me with admitting people still. Having a good turnout already. Okay, welcome everybody. Welcome to STR's Meet a Method. Today's topic is generative AI as a research tool. This virtual STR Meet a Method is brought to you by the Membership Engagement Committee under Chair Andy Wu, who joins us today. Hi, Andy. Thanks for sponsoring this event. We're very excited to host this event, and we had a lot of interest and anticipation over the last weeks leading up to this event. And this wouldn't be possible without the real cool panel that we put together. And I can't wait to see what the panel has to offer today. I already heard a few things, and I'm very excited about it. So let me start by introducing the esteemed panelists that I could secure for this event. Elisa Alvarez-Garrido from University of South Carolina is joining us, as well as Andrea Contigiani from Ohio State University, Carolin Häussler from University of Passau. And I'm lucky enough to share some of my experience with you as well. I'm Daniel Albert from Drexel University. I'm also organizing this event. So I don't want to bore you more with what I have to say. I want to hand it over to Elisa and hear what she has to offer on this topic. Let me stop sharing my screen so that you can actually. Okay, perfect.
Hi, everyone. Thank you, Daniel and Andy, for organizing this panel. I am looking forward to the presentation of the other presenters, in fact, to learn more. But hi, everyone. I'm Elisa from the University of South Carolina, and I'm being tasked with kicking off the panel and talking a little bit about generative AI as a research tool more generally, and the other panelists are going to give us examples of how this has been used in the research. So the first thing about this seminar is that as of 10:04 this morning, it's already obsolete, most likely, right? It's changing so fast. So this is exponential improvements that we are experiencing. And so rather than dive into the details about what we do today with AI, I wanted to give more high-level comments about how one uses AI more generally and how you adapt to the constant change with more high-level tools. So first of all, I think it's important to understand that there are two distinct categories in AI. that are relevant when we're thinking about research. First, we have the foundational LLMs, which is basically the models that they train on vast amounts of data using a ton of like servers and electricity. And these are basically the basis of all other AI models. And then we have AI agents, which are really leveraging these models and adding functionalities to them so that so you can basically use the LLM directly, or you can use a model that has taken that LLM and added some functionality.
Elisa, real quick, like, are you showing slides?
I am. You don't see them?
I can't see them.
Okay. Yeah, way to start.
No,
I can
no
see
worries.
them. I can see
I can
them.
also see them.
You can, or you can't? You can? Okay, so then it's my issue. Oh, I'm so sorry.
I may have blocked you when I stopped your presentation.
Okay, I can see it now. Thank you.
Super. So AI basically in research, as in all other facets of business, is a productivity multiplier, basically. So I wanted to talk a little bit about aspects of the literature review, writing, coding, and less about data cleaning and analysis, since the other presenters are going to be focusing more on this aspect. With the literature review, it's been evolving as to what extent the AI could do a decent job. I think and it will continue to evolve. I think it's at the point in which it does a pretty decent job. But for the most part, the way to evaluate how good you're going to get a literature review about something you don't know is to start with the topic you know very well. And that will help you test not only the AI capabilities, but also the prompt that you're using and what you need to tell the AI to really do a good job. So I just did like a very quick, very simple prompt that is probably not ideal without giving much guidance. And I tried this on Perplexity that has access to the deep research model from OpenAI. And you can get 3 of these for free a day. So, you know, if you don't want to pay 200 a month, it's something to take into account. And it did a very good job. I also tried on Grok and on ChatGPT. And so what's the verdict? How do AIs, how can we use them? They provide a great start. I wish I had had this when I was a PhD student. And you have this fire hose of information in which you don't, or when you're reading a new literature where you need to read like 20, 30 papers to start getting a grasp of what the literature is about. This provides a very solid start to do that. It provides good organization of topics. So I think in terms of what are the mechanisms, what are the main aspects of the literature, is doing very well. The literature is incomplete. I mean, there is no AI so far that has provided me with a list of, that provides a very complete list of references. So you need to be aware of this. If this is not a topic you know and you're truly doing a lit review for the first time, but what you'll have is enough references there that you can start pulling thread by looking at the reference list. So basically, it's a start. It's not the end product, but it definitely saves a lot of time. So this is one thing in which you can definitely use AI. Writing, of course, I think this is what everyone is using AI to start with. But so what's the verdict on this one is it's a very capable writer. It really does very, very well. And I think you need to experiment with the prompt of providing it enough guidance. So basically, if you do a prompt, it's an experimentation. You do a prompt, and if you don't like what it speaks, then you modify the prompt to tell it not this way, that way, until you kind of get it right. And eventually you learn to talk to the AI in a way that you get faster the results that you are looking for. Now it's very pompous. I mean, truly very pompous writer. So what I do is I always start by feeding my papers for tone. And I say, this is what I've written before. I want you to write with the same thing. And it helps break that like white page, block that we all have at the beginning. So you will end up rewriting everything, but as for a first draft to work on, works very well. It's also quite creative. So when I use it, sometimes it gives me ideas I have not thought about. So that's something to praise of this tool, but you need to be aware that sometimes it's a hallucination. It makes up literature doesn't exist. It makes up, so you cannot really trust what it says. But that hallucination can be a source of creativity, and so that's a good thing. Now, the problem with this, with writing especially and coding, as I will talk, is that threads grow fast. And so if you understand how the AI works, basically every time you start the thread and you give some parameters, and then the conversation continues, and every time the whole conversation is fed back into the system and then it spits out. And so by the time you've been talking to this thing for a day, the conversation is so long that the AI can barely manage all this amount of information. And so what it does is that it may weight higher the last conversation. So it's like it forgot what you told it at the beginning. And so it starts to be very slow because it just has a ton of text to process. It's not that they are blocking you. It's just you're feeding too much. Even if you're feeding a word, the program is feeding the whole conversation back every time. And so to keep threads manageable, at some point in time, you need to start a new thread. But when it's working very well, you don't know what to do. So my tips here is first, experiment with the initial prompt and save it. If it has worked, go back to those initial prompts and even ask the AI to summarize what the conversation has been about, what the current topics are, and kind of create an initial prompt that will quickly replicate the behavior of the previous one. And so, so you're basically, instead of passing the whole conversation, purposefully choosing what context you're passing on by starting a new thread. And so once you learn to change threads more often, that also increases your productivity. Otherwise, sometimes you can't get a coffee in between response and response, which is not as productive. Now, one thing I've been using AI a lot, and maybe some of you have been using less, is coding. And so this is both to supercharge, like a fast track all procedures, and also new things we couldn't do before. So what do I mean with all procedures? We have all been programming in Stata or R. Some of us have been programming in Python or similar. So in my in my dissertation, I was web scraping, and so I had to go on a 1 month detour to learn how to web scrape and how to code this with regex and all that. And Felipe Chazar was very kind and taught me. But the thing is, this was very slow. You can use AI to do all this programming for you, and so basically you can ask to generate a graph with all the conditions, like in a Stata, graphs are a pain in the neck. You can tell it, I want this line like this line like that, and get it to produce the whole code for you. And so this gives you a lot of control because it's the same thing you've been doing before, only you're doing it faster with the help of the AI. Now, what's interesting, and I think this is where more of the power is going to come, is from the new procedures that we just couldn't do before. Well, we would tell a research assistant, right, like an undergrad, hey, go do this, go do that. And then we would have to train the research assistant. So that same thing you are starting to be able to do with AI. And I think we're going to see a lot more of this. And so, for instance, operator, which is it's a pretty penny because it's 200 a month. But if you compare to the price of labor, might not be so much. Operator can replicate things that you do on the web for you. So it can basically, where before we would be looking for information, operator can be looking for this information for us. Box has developed tools to do procedures that are automatic with files that you have on the Box folder. So you can put documents there, like say annual letters from shareholders, and kind of get it to do some processes for you and create a database. And Manus is a very new AI from China. There's a lot of hype. I don't think it's still available, but it does a lot of these things for you. And I think very soon we're going to see tools that can interact with our computer, and kind of that will give us a lot more power. Now, how do we know it's doing a good job? We don't. And in fact, sometimes it isn't. And so, but it also make mistakes. So we know what to do, basically. And my advice is do the same things that you do with your arrays. Check a random sample, see if it's getting it or if completely messed up what you asked it to do. And then if you think it's doing a pretty good job, do it all over again in a fresh thread without the information. So, and then compare. So basically, this is a problem of intercoder reliability that we know well how to address. And as to close, I wanted to also mention that because all the tools that we are using, be it a foundational LLM or be it an AI agent, they are all based on these LLMs of base. We are basically leveraging whatever biases have been built in terms of the training data or additional layers of biases that sometimes are built into these tools. Even the AI agents that leverage them have these biases. So you just need to be aware. And importantly, also data privacy and confidentiality. So I was working with an organization for which there was a very strong NDA, and I could not use many of these tools because you don't have a complete, you cannot be assured that it won't end up in the training data somehow, even though they tell you it won't end up in the training data, but they cannot guarantee this confidentiality because the AI in a way might remember. And so you just need to also be aware that some of these tools will be able to run locally, but that's also a big effort of setting up locally in your computer, so you don't have a confidentiality issue. But as of now, if you're running this on the cloud, you are subject to I think it's a relatively decent privacy setting, but not foolproof. And just best way to learn is to experiment. I mean, I understand it can break the bucket, like these AIs can rack up. But I encourage you to get a Perplexity just to try them all. It has a lot of models behind it that you can talk to just for a few conversations a day, and it gives you a sense as to what might work. You can try the free settings and then choose the one AI that seems to help you more, so that you are not paying a ton of subscriptions. And that's all for me. Thank you very much. I look forward to your questions at the end.
Thank you, Elisa, so much. This was very insightful. Thank you. We have quite a few comments and questions in the chat. I will hand it over now to Andrea. And we will monitor the chat to the best of our abilities. There's a lot of demand right now, which is really great to see. Thank you again, Elisa, and we will follow up. Andrea, you're ready to go?
Yeah. All right. Hello, everyone. Good to see you. I'm going to share the screen. Can everybody see the slides?
Yes.
Okay. Well, first of all, thanks, Daniel and Andy, for organizing this event. This is super interesting, and thanks, Elisa, for the nice overview. And by the way, I see lots of old friends in the room. So hello, everyone. So I'm Andrea. I'm at Ohio State. I'll talk about sort of a bit of a specific case, how to use this technology in studying early stage firms. Okay. And before I start, I sort of want to give you a little bit of the way I view this very, very briefly. And you can think about, very, very loosely speaking, firms make some sort of product and they follow some sort of process, and the combination of those generates performance, right? And again, very loosely speaking, you could call the combination of product and process strategy. I know that purists of strategy theory will have different views, but broadly speaking, this is one way to think about that. So companies do all of these things and that generate performance. And it's very interesting to me that this technology, generative AI, affects this picture in a number of different ways. And obviously, it affects the way we look at it from the outside as researchers, right? And the obvious way is that it affects the process that firms use. Lots of interesting research on how companies are using generative AI and how that's changing their performance. Lots of different angles there. This is maybe the the angle that as a community we've taken that affects, there's more activity at the moment. There's also some work that is about companies that are actually building AI, right? Where AI is their product, not their process. This is a little bit of a newer niche, but there is interesting work in that space. And of course, there is also a lot of work on how to use generative AI from the outside for us as researchers, right? AI as a research tool, which is obviously what we're going to talk about today. So as I was observed this technology emerge, it's just really interesting how, unlike most other technology, it affects both what we study and how we study. And I think that's sort of really interesting. I'm going to talk about specifically how to use this technology as a research tool in studying early stage firms. And the reason why I think that's really interesting is that it's quite hard to study early stage companies. And it's hard because data access is very limited. These firms are not required to disclose. There's some data that you can buy, but they're very expensive. And even so, the data usually are not great. They're not systematic, they're unstructured. And that's why in a lot of this research, that, let's say, falls at the intersection between strategy and entrepreneurship, we do a lot of human coding. And there's a whole methodology around how to do human coding. Krippendorf is one of the key references. But of course, the quality of human coding is sort of questionable. And so I think this is really where AI can be helpful. I'm going to talk about briefly talk about 4 experiments I've been playing with. I'm by no means an expert, but I've just been trying lots of different things, and I'll talk about 4 of them right now. First is how to quantify change. The second is how to classify markets. The third is how to identify strategies. And the fourth, how to measure performance. I'm in different places across these four things, but I'll talk a little bit about each. So let's start from change. This may be the simplest thing that I've done, and I think it's worked quite okay. So one of the things that we're interested in early stage companies is the degree to which they change, right? We often talk about adaptation, about pivoting. This is sort of a very important feature of companies at the early stage. There's lots of theory on this, but empirically, this is hard to do because of the lack of data. So what I think it's a good way to approach this is to use to collect pitch decks and collect pitch decks from new ventures at different points in time. So you sort of start from that point. This is sort of a structure of a setting that I've studied where these startups were presenting their ideas at 3 different points in time. So we could collect the pitch decks at time 1, time 2, and time 3. So obviously, once you have that, you can start using that data. And the obvious thing to do is to feed this pitch deck into some generative AI tool. And the way I've done this in this setting, I still leveraged human coding, but I found that it would have been really hard to ask humans to essentially to quantify change across different pitch decks, because these pitch decks have very different outlines, very different visuals, very different formats. And so quantifying change is actually quite difficult. So what I did, I put them into a generative AI tool. In this case, it was GPT-4o through the API that OpenAI offers. And I asked the tool to generate summaries. And this is an example of an anonymized example of a summary that it created with a little bit of a structure that I imposed: overview, problem, solution, and market. And once I've done that, and you can see, the quality obviously is pretty high. Once I've done that, I asked, I gave all of the summaries to a group of human coders following all of the standard practices from content analysis. And I've asked them to quantify change along a series of sort of well-defined dimensions. And so I thought that this sort of was like a very simple experiment. I think it worked pretty well. So this is the first step. Second step, how to classify markets. So something that we often have to do in research and entrepreneurship is to assign each startup to a market. Now, in strategy, that's less important, partly because a lot of large companies, when you study large companies, they're diversified, there are multiple markets. And in most cases, you can get the market data from things like CompuStat. But in startups, we can't really do that. And that might be important. For example, if you have to run a definitive study where the treatment happens at the market level, you really need to know which market each firm is in. And this is hard partly because markets are not well defined, and this data is not really available. But sometimes you really have to do that. Obviously, I've had to do that in my own work. I was trying to run a definitive study, and it was important to understand which market each firm was in. So I created a categorization of markets for the software industry. And then I gave sort of this code book to a number of arrays working independently, and we've done it that way. It took many months, good amount of money, but the product was quite fine. So the way to approach this now would be to collect information about ventures. If you're using Crunchbase, just a description might be enough for this specific task. You create the market categorization that works for your specific study. That may be question specific or industry specific. And then you feed the description into the LLM and ask the LLM to assign the markets. Sometimes, you could do what people call few-shot learning. You could have a group of human coders do a small sample of that and then feed that in. But it's actually, at least what I found, is doesn't change the performance that much. So this is sort of a little bit of a prototype that I've done using ChatGPT-o1 through the web application. The classification that I used has 27 markets, and it did a really, really nice job, just with very few pieces of information. And obviously, you want to kind of like following what Elisa mentioned, you really want to validate this with human coders and calculate this reliability measures. There's lots of those measures that you can use. So this is number 2. I'm going to go to number 3. Daniel, can you give me a sense of how much time I have?
You have a couple more minutes ago. How much do you need?
I can go quick. All right. Third step is how to identify strategies. So again, you may have to want to identify which strategy each startup follows. There's some work that does this that's done in the past, typically looking at differentiation, and differentiation is a little easier because it's essentially a function of distance. You can do that. Through calculating some sort of distance measure. But with strategy is broader, and you might want to do them more holistically. I'll go quick here, but you could use a frame. There's lots of different strategy frameworks. One of them is Gans and colleagues. LLMs might do this quite well. So what you would do, you generate your strategy categorization, you collect as much information as possible about the ventures. In this case, the problem is a little more complex, so you really need, I think, a lot of information. Feed that into the LLM, and the LLM would estimate the strategy. This is a prototype that I did. I thought it worked out sort of quite well. I'm still sort of working on this specific case. I'm trying to scale it. As always, you can prototype with a web interface, and then you scale it with the API. But this needs a little more work, but I think it's quite a promising thing. Last thing here, how to measure performance. Very hard to measure performance in startups because there's no sort of financial measure that you can use. One approach is to evaluate the ideas. Again, you can do that through pitch decks, and LLMs are actually pretty good at evaluating pitch decks. You have to prompt them really well and really have them behave as investors. I've done a couple of different experiments here with ChatGPT and with Llama. This is an example of an evaluation from another anonymized pitch deck. There's some sort of grammar issues, but actually, I think a lot of those typos come out from the conversion of the data, so it's not really the LLM. But in general, you can see the quality is pretty high. However, I went then on and looked at the correlation between these evaluations and human-based evaluations. Correlation was actually pretty low, unlike what some of the literature suggested recently. I'm now testing a new model where I use this RAG approach, which some of you may be familiar with, and I don't have clear data yet, but actually the anecdotal results look very promising. And so actually with this approach, this will get even better. All right, I wanted to close with some final thoughts. I don't think we have time for that, but I'm gonna just leave them here.
Take your time for this. You have,
okay.
You have time.
Okay, then I'll take the time, just 30 seconds. I just wanted to, these are just 4 experiments that I've been playing with in using AI as a research tool in entrepreneurship. I wanted to sort of think about the big picture at the end. And there's 4 sort of type of issues I've been thinking about. One is how to deal with the institutional resistance. Lots of universities, including, lots of universities, let's stay there, are very resistant to this technology for a number of issues, some of which Elisa mentioned, like privacy, like confidentiality, and so on. And obviously, this is tricky because to learn the technology and to use it, we really have to play with it. And if the institution doesn't let us do that, then it's tricky. And I honestly see a lot of inertia there. So I think this is a bit of a difficult battle for a lot of us. So I hope things will get better. Another question that that people come up with, people talk about, is how to deal with the change in Gen AI capabilities. This is also something Elisa mentioned, right? These tools change very, very quickly. If you write a paper today and then 2 weeks later the tool is different, is that paper still valid? And that's actually quite a problem. I don't know. I don't know how to deal with that, because it is true that if your results change radically between ChatGPT 4 and 4.5, it's kind of hard to say what to do with that research. More futuristic discussion, could Gen AI replace the entire research process? In a lot of ways, I think it actually could. We can really think about that, maybe some other time, but I think we really had to ask how we can add value in a research market where Gen AI can do 90% of the work. What do we actually contribute? Final point here. This is something I've been thinking about for me, for my own career, and for, I'm talking about with some senior folks, with some junior folks. Does it make sense to get into Gen AI at this point? You can, and there's 2 strategies. You can follow the trends and get into Gen AI, even if it's a little late, or be a little bit of a contrarian and try to stay outside and differentiate. And initially I thought, well, maybe it makes sense to actually stay outside. But then, I think I actually changed my mind, because I think this technology is so disruptive that we're all gonna have to use it. There's really no alternative. And so I think it's really kind of useful for most people to really, really understand and experiment with it. All right, that's all for me. Happy to chat more. Thank you very much.
Thank you, Andrea. Thank you so much. And I'm glad you took the time for the closing thoughts, because I think there's lots of food for thought right there as well. So I want to hand it over to Carolin Häussler from University of Passau. Please share your screen. Thank you. And I'm looking forward to your presentation. Thank you, Carolin.
Okay. So thanks, Daniel and Andy, for initiating and organizing the panel. Before I introduce you to how we apply AI in our research and strategic alliances, I'd like to start out a little bit more general. So I think we are now in the 4th scientific paradigm. The first paradigm has been about empirical observation. So scientists observed nature, Charles Darwin. Then in the second, scientists doing theoretical models, Albert Einstein, computation science as a third leg. So used simulation, creation of numerical models to understand behavior. And the 4th scientific paradigm is said to be data intensive science, so focusing on extracting knowledge, insights from large-scale data. And the goal is often to extract patterns from unstructured data set. And I will show you that this can be quite powerful. So I and my co-authors, we use AI in a number of projects, such as measuring innovation with AI, also detecting patterns in open source software and so on. But for the moment, let me just focus on strategic alliances. And maybe before I start, let me point out that I was trained in a very different approach. Most of my work is deductive, so I build theory, derive hypotheses, and then test it, and most often with large-scale data. So how did we come to data-driven science and kind of applying AI? I really would say it was serendipity on the campus. So Dorte Loisman, you see her on the left-hand side. Dorte Loisman is a postdoc at Majer. She's now on the job market, so she's fantastic. And we share an interest in how alliances, strategic alliances change over time. So adaptation of contracts and so on. And what we found out when we looked into like what changes in these contracts, it was mostly definitions which change, yeah? And we built a huge alliance database with more than 12,000 biopharmaceutical contracts. I mean, this is a really huge database. And then we run into, on campus, literally, into Florian Lemmerich. And Florian is running a chair in computer science, and he develops new machine learning methods, yeah? And really pattern recognition, all these kind of stuff. And he said, this is really interesting what you have. Let's just try out with AI and machine learning. So how our methods work in your like real world setting. And he brought Max Kreutner on board, who is now a PhD student in computer science at the University of Mannheim. So, and yeah, so we joined forces, and what we did, started a project tracing definitions, lessons from alliance contracts in the biopharmaceutical industry. And so I said we are really interested in definitions. And so definitions in a contract are exact descriptions of key terms used in the contract. Like here you see the definition of commercially reasonable effort. So that's the definiendum. And this is then the second part. The definiens is kind of defining this definiendum. Yeah. And these definitions kind of shape interpretation of the contract. Yeah. And as I said, this is like what's mostly changing when you trace strategic alliance contracts over time within the same partners. So are these definitions important? They are very important, because when they are not done properly, this may create costly misunderstandings and even turn into huge disputes. And I provide you with one dispute. That's the European Commission versus AstraZeneca case in August 2020. It was about delivering the COVID-19 vaccine. So we all know we were desperately looking forward to get such a vaccine. But this dispute on this definition halted the collaboration for nearly half a year. Yeah. And this was about what is best reasonable effort. So this is like our interest. Now, you know, strategic alliances in biopharma are really important. There are a growing number of alliances and so on. And in that project, we were particularly interested with computer scientists to extract the definitions from these PDF contracts, to look into like which definitions are more similar and where do we see more heterogeneity in defining it, what kind of topics cluster together, and also temporal patterns over time. So after collecting the contract PDF documents, we turned them into text via a Python package. And then we use different automated methods, like 1, 2, 3, to identify and extract the definitions. And then we evaluated the methods based on a subset of more than 800 alliance contracts that have been annotated by humans, so Dorte and we did this. Like the first approach, so-called sentence boundary detection tool, finds it. This is about where a sentence begins and ends. When you compare it to the human coders, it finds fewer definitions than the human annotated coders, and has a median error rate of about 6 definitions per contract. It also failed to identify definitions in full length when definition text spans over multiple sentences. The second proved to be the best one. That's regular expression. So mainly it searches for common words, expressions, and phrases. It finds slightly more definitions than the human coders, and has a medium error of about 3 definitions per contract. And we identified more than 450,000 definitions with regex. We also applied large language models, Gen AI, and this worked well for short contracts, but it really struggled with longer contracts. So even when we set the temperature to 0 and sample size to 1, the large language model hallucinated. So it included definitions that are not really written in the real world contract text. So I think this is also important to know that Gen AI is not always like the best method. Maybe there are other not generative AI methods that score quite well. So next, we were interested in how similar are the definitions across contracts. And here we use transformer-based models. So SentenceBird for sentence similarity tasks, and GTE, that's general text embeddings, for text understanding. And then we use Cousiny similarity to find definitions that are semantically similar, and the ones who vary more across the contracts. And on the table on the right, you find at the top definitions which are very similar. And you see these are mostly legal definitions. For example, IRS stands for Internal Revenue Service. That it's a text expression. I mean, it's not surprising that this is always defined the same. But what really had a lot of heterogeneity was the more social definitions, like what are parties, what is collaboration, and so on. What we also did, we also identified definienda with the same very similar definiants. So like, for example, here, manufacturing costs, the plural, I mean, that's similar to the singular manufacturing cost, but also cost of goods were defined very, very similarly. So then we were interested to identify clusters of definitions. And here we use pre-trained transformer-based language models like BERT topic framework, and usually embeddings that lie closer together in a vector space are covering the similar topics. So clustering methods group embeddings that are closer to each other simply. And then you can identify different types of topics, like is this more social, technological, or legal? And then we were interested in tracing the temporal patterns. So on the left, as you see 3 graphs, the first graph shows the contracts, the number of contracts that contain like definitions, alliance contracts. You see this is increasing, and it was like the highest number appeared in 2006 and 2008. So that was the time of financial crisis. So this is also interesting that we also observed that like definitions are becoming more important in tougher times, as I would say. The second graph shows the average of definitions per year. The last year is a censoring thing. You see that's kind of increasing. And the third graph shows the average number of definitions per contract per year. And you see also, I mean, this is increasing. In 1988, we had very few contracts, that's why. But in total, so it's increasing. So on the right, we use dynamic topic modeling, and there are also various approaches that the computer scientists evaluated. We use that to discover trends among different topics over time. And as you can see, the dark blue line, this is increasing, and this line is related to common stock, company shares, and so on. So my more financial aspects. Probably this is increasing because of like increasing drug development costs, M&A activity going on, changes in ownership, and so on. Interestingly, the red line is decreasing, and this red line is more related to technical terms. Yeah, what is the combination product, and so on. This is also what we see in other analysis we did. So let me briefly come back to the AstraZeneca European Commission or dispute. And here it really appeared that the best reasonable effort definition that they used was indeed very unusual. Yeah. So the mean Cousiny similarity score among the other definitions were much higher than the one from the AstraZeneca and EU case. It appeared that 89% of definitions in our contracts that had this best reasonable effort definition have a higher similarity score than this one. Yeah, and I think for me this was kind of eye-opening because the AI helped really to to also kind of detect the unusual. Yeah, and we all know it's always better to look on the outliers. Okay, so I think time is up. Let me briefly finish. Yeah, you see a lot of text on it. I won't go through it, Daniel, no fear. The data-driven method, I would say, helped us really uncover patterns that, or in a way, we could not do it before, and also at a scale that we could not provide otherwise. So remember, we had more than 450,000 definitions. No way a research assistant can go through it. And maybe more on a personal note, I really experienced how fruitful, important it is to work interdisciplinary here, because we went forth and back with Florian and Max, with the computer scientists, to understand, discuss what one can do next. We learned about opportunities, about newest methods, also about limitations. And I would say, like, Dörte and my contribution was to kind of provide insights and context to it, and sometimes maybe added some meat to and reason to the results. And yeah, so summing up together, I guess we could do and create much deeper insights than either discipline alone could achieve. And yeah, so let's break down the silos between the disciplines and join forces. And also, it is really a lot of fun when you work with them and they show you all these magic methods and so on. Yeah, thanks.
Thank you, Carolin. So interesting, very, very engaging. Thank you very much. Let me share my screen real quick. Okay. So I assume you can see my slides. A quick thumbs up. Thank you. So I'm very honored that I'm allowed to also share a few of my own experience and thoughts, like, given that the three panelists have already provided such rich insight. I just want to add a few things from my own experience. And so I want to start with, like, the way I think about how generative AI might augment our research, particularly in management science. Note that this is highly opinionated and highly incomplete, so take it with a grain of salt, but that's like how I like to think about it. So to me, there's one pillar, personal assistance in ideation, where it's really about AI becomes a coach, a second pair of quote unquote eyes, a sounding board to our research, right? We've heard about writing, copy editing, researching ideas, summarizing translational work, and so forth. Then there's data processing and analysis as a second pillar, right? Here, AI can be instructed and trained as a research assistant, an RA, right? Or even a co-scientist, where can help us with computer coding, programming, labeling of data. We've heard all of this already, right? Data extraction, transcribing, and so forth. And then there's a third pillar where Gen AI can become like simulation and generation tool, where we potentially can reproduce human data with AI, where we can pilot experiments with synthetic data and analyze reasoning that LLMs and other generative AI tools mimic of human behavior. Here, I argue that AI can become a true, real research method. So let me get to the next slide here. So I want to briefly share my experience with labeling of data and a project where we reproduce human lab experiment data and simulate human thinking. So starting with the labeling of data, we've heard it before, right? Like labeling, or sometimes called coding of data, where we want to assign categories, variables to unstructured data, is really challenging, right? And so traditionally we've used researchers, research assistants, RAs, right? But it's difficult to, first of all, train others to communicate how we want things to be coded. And then there's huge inconsistencies among humans, like especially if it's multiple humans, but then also oftentimes these coding tasks go on for months, right? Because it's such vast data, and we are all humans, so our attention fluctuates, right? So there's the risk of inconsistencies. And to be honest, like for many tasks, the cost is substantial, right? In terms of time, but also money of labeling large data sets. One approach has been, and is a very powerful one, is that we program algorithms, right? Like that, almost like if-then rules. But the problem is it's limited in understanding nuances and context, right? So plus the more specific I define an algorithm, the more impact it has on how it codes data in a particular way. And so here I enter as a suggestion large language models as a form of generative AI. And here the advantage is LLMs are designed to require little instructions, and they're trained on vast amounts of human written data to understand context and concepts without additional training needed, right? So I want to give you an example of a project that I'm part of together with John Eklund and Lisa Tang, where we collected 140,000 executive year observations of S&P 500 firms over 30 years. Here we have the names of the executives, we have the official title, and so our challenge was like, we want to categorize these titles into specific roles and ranks, right? Like a role is, for instance, chief financial officer or responsible for a particular business unit. And rank is it a CXO? Is it a vice president? Is it a senior vice president and so forth? And these roles are sometimes, some of them are easy to classify. Others, like business units, are often very context specific. And so we found like that after using RAs and using our own abilities and programmatic algorithms, we found that the results were not very satisfying. And then we ended up instructing and fine-tuning large language models based on our own specified training data. And we fine-tuned ChatGPT 4.0 model and a few open weights model like Llama and Mistral. But fine-tuning is really different from just giving instructions. You give instructions, but you allow the LLM to learn and basically freeze that additional knowledge in its weights. And then you can reuse this newly trained model over and over again. No matter if OpenAI or others make changes to their models, becomes a new model that you can then use for this task. And so the results that we achieved were incredible. In particular, we found that the 140,000 executives that we needed to label, we labeled actually in a few hours with the LLM. GPT 4.0, the fine-tuned model that we created, had a 98% accuracy rate that we tested in a holdout sample. So something that it's never seen on the training side. And that's higher than what we as an author team could achieve. And the cost for labeling 140,000 executives was $150, right? So it really addresses multiple of the challenges that we've faced before. Now let's move on to the simulation and generation of data, right? So we're interested in studying human cognition and decision-making in our research. And so we were wondering if LLMs, large language models, as a form of generative AI, can become an additional, a complementary method to how we have studied human behavior so far. So far, we have used lab experiments, computer simulations, in the best case, fMRI brain scans to really look into like what's going on there, right? And multiple variants of these things. And that's great, but it's, again, expensive, very limited, a lot of IRB control over this. And so the question arises in the field, can large language models become a new research method to study human cognition and human behavior? And there's economists who already basically said like it's possible that LLMs can be treated as human-like agents that simulate human behavior, mimic it, and we can use it potentially for piloting studies, simulating experiments first before we actually go into the real world in the lab where conducting this research is expensive and our n is usually relatively small, so we don't want to mess it up. So together with my co-author, Stefan Billinger in Denmark, we asked ourselves, can we use LLMs to simulate human thinking as management scholars? Can we actually reproduce a real human lab experiment from behavioral strategy? And if we can do that, we ask ourselves, can we actually extend what we can learn from experiments by simulating human thinking's why agents or quote unquote humans might make a particular decision in a particular context? And so we replicated a real lab experiment, a human lab experiment, where we basically gave the exact same experimental setup to artificial LLMs as treated as agents. We gave them basically as a system prompt, like here's like the experimental setup, very similar to what the humans would get. And then the LLM agent is asked to make a decision based on what's presented to them. Then the program that we wrote provides feedback to the LLM, and the LLM basically reflects on this feedback and makes the next round of decisions, right? And so we do this over 25 trials, and we do it like multiple hundred times. Basically, each experiment is like treated independently from the others. And create, in that sense, artificial lab experiment data. And so what we found is, you see in the red line is the actual human data, and the blue line is data that we generated from large language models. And what you can see is like on the x-axis, the number of trials that I just mentioned, and the y-axis is a form of like a exploration measure, right? So per trial, like how much does the agent or the human explore from the status quo, right? And we see that actually we get very similar behavior in terms of it mimics it very closely. And if we use, as in this case, multiple LLM populations, so in this case, we use ChatGPT 4.0 and ChatGPT 3.5, we actually get variance that's also very alike to human variance. If we only draw from one LLM population, like GPT 4.0, we see smaller variance. But so we answer a question like, in this particular experiment, we find that LLMs can actually mimic that behavior pretty accurately. And then we wondered like, okay, now let's read out like it's quote unquote reasoning why it makes certain decisions. Maybe that informs how humans actually make decisions. And LLMs naturally write out their decisions because it generates text. And we quantified this text into to which extent is the text forward looking, to which extent is it backward looking? And we ran regressions of like how this relates to the decisions that it makes. And we found that a greater forward looking ratio of quote unquote thoughts in the LLM is associated with higher exploration and a bunch of other things. And so now we consider this like, hey, this is a way of like how we might form a real new hypothesis or a research question. Does planning or forward looking actually lead to greater exploration? And so now we could go back into the lab and test this, right? So it's not meant as like the ground truth, but something to stimulate some new thoughts, or as Carolin said, like finding some blind spots that we might not have thought about. So again, that was like the two areas that I wanted to discuss with you. I'm sharing here also a couple of like that I find useful links of like how to use OpenAI's API, the documentation, fine-tuning, links to our working papers on this topic. And at this point, I'm yielding back and would like to get back into my role as the organizer. And first of all, very sincerely thank Elisa, Andrea, and Carolin for taking the time and sharing such amazing, insightful thoughts. And I want to open the floor for a few questions if people have some. Like I saw that the chat was pretty rich in questions, but I also took notes on a few questions if they are not immediately in there things. Is there anyone who would like to ask a question to any of the panelists? Please unmute yourself if you would like. So I would like to start because I don't know if people are able to unmute right now. I would like to ask one or two questions. One question that's came up during Elisa's talk, like using AI for programming and coding. How do you ensure or double check the code that it doesn't just work on the surface and seems to be doing what it's doing, but that it actually is programmed in the right way, so that errors that you might not see immediately are accounted for?
I think it's the same problem as when we're programming anything. I've been programming like a database in Stata to find I had made a major mistake 6 months in. I had to go back and rewrite the whole thing. This is pre-AI. So I think it's the same thing. You still have to follow the same, especially with data, you still need to make sure that do cross sections and check. You still have to check every step of the way, basically. If you're programming something like I've been programming some web scraping, then it's easier because you see if it scrapes the web or if it doesn't. So, but when it comes to data, you always have to just go step by step, just like you would do it for you, and check it makes sense. Yeah, or do it twice also and see if you're getting the same results.
Thank you. I see we have a question in the chat. Contigiani?
Yes, hi, thank you so much. I tried to find out my camera. Anyway, yep, here it is. It's great presentations, all of you, I really appreciate. My question is because I'm using AI for article, and then I would like to suggest when you plan to submit a manuscript and you use for your analysis AI, what challenges probably you have to raise, what limitations you have to add in your manuscript, and how you can support that, because this is so important right now.
Yeah, who would like to, I know Carolin, we briefly talked about this. Would you like to go first? Otherwise, I can share some thoughts as well.
Maybe so for the project I presented, so we submitted it to a computer science conference because I mean it's a methods paper at the moment, and in terms of our publication and very long review process, this might be a challenge. But I mean, using that method, if it's not a method paper, but using the method to, I don't know, define definitions that we then do in a more usual paper style for our journals, I think that that's good. We did this in the SMJ paper that came out this year we did a measure on cognitive frame similarity with machine learning, and then we published also the algorithm. So I think that's maybe important to really make open and disclose the algorithms, and maybe if you can, even the data.
Thank you. Any other thoughts?
Yeah, so Andrea, would you like to share your thoughts?
Sure. My sense is that, and I don't know if I fully understood the question, Antigone, but my sense is that, there's lots of, let's say, ethical issues that we want to think about in using AI, some of which are new because we're using it in some sort of new ways. The way I'm mostly using it is sort of as an input to some sort of statistical analysis for now. And there, it's not unlike some other software that you're using. So I think as long as you explain that carefully, that's fine. Like it's a little bit like using a Python-based library to calculate some variables. I mean, it's not that different, I think, from that sort of thing. On the other hand, I think I've seen some interesting discussions on issues, statistical issues that come up when you use AI to build some variables. There could be some new, issues that we have to think about there. I'll post on the chat some work I've seen recently. I'm following that, but I don't have a clear view. But I think that's something that we want to think about. A lot of the statistics that we know is based on the pre-AI world, and using AI, does that change anything? So I think that's what I would think about.
Actually, I was thinking about the document analysis when we use the AI and then we use the human for reliability. This is mostly not about statistical, but also, you take the PDF or the test, you find out all those information, and then you have human, you train them to identify similar issues. However, I was thinking about the limitations that you have to add to the manuscript. I'm working right now. That's why it was very interesting. Yeah, especially I believe Elisa's work will be relevant.
So I'll post a couple links in the chat that might contribute to that discussion. But it's a good problem to think about.
And so I would like to offer one more. Lucy has her hand up. Please unmute yourself, Lucy, and
Hello. Can you hear me?
yes.
Yeah, thank you so much for a great talk. And my question is to ask Andrea, because she said that for the using AI tools for large-scale internet search, and I think that she said if I have articles through Vectiva, actually any LLM can process them quite well. So far I have like 10,000 more than 10,000 articles from Vectiva, and how I use LLM to do this job. Do you got what I mean?
Sorry, I didn't fully understand the question.
Okay, so basically, I have more than 10,000 articles that I collect from Vectiva, and now how can I use LLM to process them? Basically, I want to identify the type of the news that I get from Vectiva. I want to categorize them into different categories, and so how can I use LLM for that job? So I need to paste one by one articles into the OpenAI and then ask them to do that, or I can have some kind of tools to put all these 10,000 articles into them and then do it in several hours. So what kind of process I should follow? Because I never done this before.
May I take on that one?
Yes.
Sure.
So I have not done this, so full disclaimer here. But my advice would be get something like Operator. So this is not very cheap. It's like 200 a month, but you could get a month, or investigate Box. So I know Box is working on providing AI capabilities to their users, so that if you upload all those, Box is like Dropbox. So if you upload all those articles to Box, there are some automatations in which you could ask it to open each file, look for some information, etc., etc. Or if not, same thing with Operator. So you would basically record or some of these AI agents. So I haven't used them, so I don't know the specifics. But basically, the idea is that the procedure that you would follow is you open a file, you look for some information, you put it on a table. And so you ask the AI to do this over all the articles that you have on that folder. And it could do that. How well, I don't know, you'll have to experiment, but there are tools, AI agents that do that. So I would start by looking into Box and what is it that they offer, and see if you can pay a month of Operator and see if it's worth it.
Yeah, thank you so much.
Yeah, one thing to follow up on this as well is that the difference between I think Lucy, you asked about posting this into the web browser versus other ways. So one thing that's really worth looking into, once you deal with more data that you want to treat independently, you look into the API of OpenAI or other services. So basically that allows you to create an interface between whatever programming language like Python you use to make requests on a one-by-one basis, where you basically can read in a file, then treat it with the API, and then do that with the next one and automate this. At this point, I really would like to thank again, the participants, Elisa, Andrea, and Carolin, for taking the time in a very busy schedule. And I would like to thank Andy Wu again for sponsoring this event of the Membership Engagement Committee of the STR division. And we hope to see you all at Academy in Copenhagen this year. And we will post this video online on the YouTube channel. And if you like, follow up with us, connect on LinkedIn. This is certainly a topic that the last word hasn't spoken today, like it's emerging as we heard. And we'd love to stay with all of you in touch. Thank you very much, and hope to see you soon.